Hello everyone. Today we are going to discuss a question from the JEE Advanced 2026 paper 2 from the solution chapter. In this chapter, in this question, what has been said is in a solvent S, a compound B is partially dissociated into C and D as given below. B, C and D are non-volatile in nature. The molar masses of the B is 10 times the molar mass of the S. So we can write it as molar mass of B is 10 times the molar mass of S. Standard boiling point and the standard standard enthalpy of vaporizations are given. So we can write it as solvent S has a boiling point. We can write as TB naught. So TB naught has the value of 400 Kelvin and delta H of vaporization, that is equals to 10 R joules per mole. So it is given. Now a solution of B in S with an initial concentration of B as 0.25%. 0.25% is the initial concentration of B, has a boiling point of 408 Kelvin at 1 bar pressure. That means we can write as TB. TB will be 408 Kelvin for this solution. In this solution, the mole percentage of the B that has been dissociated is, so how much mole percentage of the B will be dissociated, we have to calculate. So we can also say that we have to calculate the percentage of alpha. This value we have to calculate. Mole percent, that means percentage of alpha. So how to do this question is, let us start. First, if you see here, what has been given is the concentration of B in terms of mass by mass. So by using the mass by mass, we can calculate the molality. Molality will be equals to, as we know that the percentage mass by mass or weight by weight is 0.25%, which means if 100 gram of solution is present, then 0.25 gram of B will be present. So molality will be equals to 0.25 is the given mass and the molar mass of the B is 10 times ms as given here, and divided by mass of solvent, which will be 10 minus 0.25. So this will become 9 point, this will be 9 point, because 9.9, this will be 9.75. So 9.75 divided by 1000, because we have to take it in the kg for molality. So that will be the molality. So we get the molality of the B. This is the molality of the B. Now if you see here, we have given equilibrium B to giving us 2C plus 2D. In this equation, if you see, if we assume at a T0 concentration is 1 and this is nothing, then at equilibrium 1 alpha will be reacted. So to total I value, which is the Vent-Off factor will be equals to 1 minus alpha plus 2 alpha plus 2 alpha, which is equals to 1 plus 3 alpha. So the Vent-Off factor is 1 plus alpha. So from here, what we can do is, we can calculate, we know delta TB is equals to TB minus TB naught, which is equals to I into KB into M. And the TB, we know the TB is 408 minus 400 and I is 1 plus 3 alpha, and KB we can calculate. What will be KB? KB will be equals to, KB has a formula, we can calculate KB from the R into molar mass of the solvent into TB naught square divided by 1000 into enthalpy of vaporization. When we put all the values, this is 400 square divided by 1000 into 10 R. So by putting these values, we get 16 ms KB value. So now we can put it KB as a 16 ms, and the molality is 0.25 divided by 10 ms divided by 0.00975. Now this ms will be cancelled out and this will be equals to 8. 8 is equals to 1 plus 3 alpha into 16 into 0.25 divided by 10 into 0.00975. Oh, this is 100 minus. So this is 100 minus 0.25. So if this is 100 minus, then this will become 9.975, 99.75 divided by 1000. So here also it will be 0.09975. Now if we calculate this equation, from this equation we get the alpha. After calculating this equation, we get the alpha is equals to 1 by 3. 1 by 3 is nothing, it is 0.333, and percentage alpha will become 0.333 into 100, which will be 33.33. So this will be the percentage mole of the B that has been dissociated. So the answer should be 33.33%. Thank you so much for listening.